They're young.
No, Nora yells and you talk.
Me too. I do too.
So at ski resorts, we have, they often will use steepness to rate the difficulty. So over here, we're using green circle, blue square, and black diamond. Below are the sketches of 3 of these particular resorts. So this one here, and this one here. So if we were to try to, if we drew a line of some kind, and we were trying to figure out which of these ones looks steeper, just by sight, which one looks the most steep to you? A or B, but C looks the least steep. Why? What makes it least steep is because it doesn't go up as much compared to how much it goes left or right. So one thing to recall is that if we simply just took how much it went up or down compared to how much it goes left or right, we get a number. So please use your calculators if you haven't already, and take these numbers and come up with a single number after you do the division. And I'll call on you in a second to get those numbers. Now that we've had these, and make sure you confirm your numbers, we see quickly which one is which. So this one looks like it's going to be categorized as the black diamond. And this one over here is the middle of the road. So that one looks like it's going to be the intermediate. And lastly, our green circle is going to be the bunny slope one over here, which is where I would spend my entire day. This brings us back. So this is going to feel like algebra because we're going to be calculating slope. And the book takes it even farther. It actually takes you into the equations of lines a lot more. But we're just going to focus primarily on slope. Why are we doing that? Because eventually we're going to get to parallel lines tomorrow and perpendicular lines. And what we're going to see is that the slopes have a relationship in their numbers. So in the size of the slope and how they're going to relate. So by way of review, today's review, and what we want to do is refresh ourselves about what slope is. So first off, for slope, we always use the letter M for slope, which is probably derived from the French word for mountain, which is something like monter. All right, now there are a couple different ways to calculate slope. The first one is if you're counting slope, you can just count how much it rises, goes up or down, versus its run. Another way to calculate it is to plug in numbers. You subtract the y's, and you divide by the subtraction or this difference of the x's. x2 minus x1. And later on in your mathematical career, you're going to see this, delta y over delta x. And delta is the Greek letter for the letter D, and it simply means change. This is the change in y over the change in x. How much does y change versus how much the y? This is the primary one you're going to use when you are given the points. And this is the primary one you're going to use when you're given a graph. So take, for example, right here, if we have this point here and this point here, and we want to count what the slope of the line is. This one's fairly straightforward when we are using the graph, because all we have to do is count how much it goes up or down from one point to the next, up or down, and then how much it goes left or right. So if I were to count, remember we start at 0 when we count, 0, 1, 2, 3. So this one goes up 3, and starting here, 0, 1, 2, 3, 4, and it goes right 4. So in calculating my slope, my rise is 3, and my run is 4. And those are both positive because up is the positive direction vertically, and right is the positive direction horizontally. So this would be my slope of this line here, 3/4. And all we did was count, rise over run. Notice that if I do start with the right and I go this way, go down, that now is going to be -3 because down is 3. Now this one now goes left 1, 2, 3, and 4. Left 4. Does that change my slope? No, because negative divided by negative is still positive. So notice that you can interpret slope in two different ways, in the positive direction or in the negative direction. Going up 3, right 4 is the same as going down 3, left 4. So let's look at types of slope. Types of slope. And we have 4 types of slope that we're going to take a look at. So let's see here. 4 types of slope. So I'll have 4 different coordinate planes. This first one is the most common, and this is called a positive slope. In other words, as I read from left to right, it goes up. As I read from left to right, it goes up. The next one is a negative slope, that as I read, it goes down. So we call that a negative slope. Another type of slope is a flat line, like so. And a flat line here is actually, slope is 0, so we say m equals 0. We also can call this a horizontal line. And what's the equation always look like? This one always looks like this. Y equals some number. Y equals some number. And what number is that? It's the number that, it's the x-intercept, or excuse me, the y-intercept there. So if you have an equation of a line back in algebra that says y equals b, that's just a flat line. That's not a point, that's the entire line, because the y value is always b. No matter what x is, it always takes you to whatever that b is. And the last type of slope we have is this one here. It's where I have a vertical line. And this one is actually called no slope. Another way of saying that is undefined. And let me spell correctly. Undefined. Another way of looking at that, besides undefined, is when you count, you get something like this. You get like 5 over 0. You get like 5 over 0. And because 5 over 0 is an illegal operation in math, we end up getting undefined. And that line always looks like this. X is some number. X is A, X is 12, X is 15, or whatever. So this is the one time in math where no does not mean 0. So if I said you had no bunnies, how many do you have? And you would say, I have 0 bunnies. Or if it cost me nothing, I would start at 0. So this is the one time where 0 and no do not mean this, are not synonymous. No slope is a vertical line. 0 slope is a flat line. Way of application of using our super secret formula, let's look at 10, and then you guys will do 11 and 12. It's wise for us to, every time we use a formula, to write it down. Why? Because the more we write it down, the more it's in our head. So when we have points, it's wise for us to use this formula here to find slope. It's the difference of the y's, so y2 minus y1, divided by the difference of the x's. Now notice, I'm going to go in this direction, so I say negative 4 minus 5. And since I started at the second point, I'm going to start at the second point with my x's now. 3 minus a negative 2. Notice I put parentheses there, so the double negatives don't look like some other weird thing. The key thing here is, notice I'm drawing these arrows just for show. You don't ever have to do those. But the key is that you're subtracting in the same direction. I started here, so I subtracted there. So that means that over here, I have to start in the second one. It doesn't actually matter where you start. I could say 5 minus negative 4, but then I'd have to start here and say negative 2 minus 3. You'll always end up with the same answer as long as you're consistent. Now I'm going to simplify this. The numerator is negative 9. The denominator has a double negative to get positive 5. And it doesn't really matter where you place the negative, but generally we put it outside like this. So my answer is negative 9/5. All right, the next thing we want to look at is a simple substitution thing. This one's not crazy. We just want to show you that there are two types of linear equations, forms that we're going to look at, and then we want to show you how to graph from there, and that's pretty much the extent of what we're doing. Our job is not to actually do too much calculation. Our big thing for us to remember is what is slope-intercept form, what does all this stuff mean, and what's point-slope form, like what does this stuff mean. So the first one here is called slope-intercept form, and it's sort of a crazy thing because it's called slope-intercept because there is a slope and an intercept in it. I know, math is confusing. So M means slope, and B means y-intercept. And if we recollect what intercept is, I know this is geometry, but an intercept would be the point on the axis where the line crosses or touches or intersects. That's called the intercept, y-intercept, or where the y-axis intercepts the line. All right, slope-intercept form. Now, how is this helpful? Because we can graph really, really quick from this. So just to practice, write the equation with the given information. We start off with y equals mx plus b. Again, the more we write it, the more it will be stuck in your head. And all we do is substitute in. My m is slope, so that's 3. My x is all the numbers that I can put in. And my b is negative 5. And that's my answer. That's it. Y equals 3x minus 5. Y equals 3x minus 5. We'll get to in a moment how this graphs, but we do just want to be able to interpret these real quick. All right, so point slope form is this. This one's a little bit uglier, but shockingly enough, we have a slope, that's what the m is, and we have a point, that's what the x1 and the y1 is. So x1, comma, y1, watch out that your 1 doesn't look like a comma. That is a specific point. As in the line passes through this point, 3, 7 or something. And m, of course, still means slope. Okay. So, how do we approach this one? It's wise for us to start by writing it. Y minus y1 equals m times x minus x1. Notice where I specifically put things. The m is the 1/2, so that goes there. This x value right there is going to go in for the x1. It doesn't go in for the x, it goes in for the x1. And lastly, the 7 goes in for the y1. Because y1 means it's a specific point. X means any number that you put in, you get something out, and that's what the y is. And that's why x and y are my variables. They change, but x1 is a specific point. It's actually a number. We just didn't know it yet. Okay, so when I substitute things in, I get this. Y minus the 7 equals the m, which in this case is 1/2, and x minus a negative 1. Now, many of you say, oh, but Swenson, x minus a negative 1 is plus 1. Yeah, so you could have started that. But I just wanted to show you the substitution, and then we simplify. So my final result is this here. Always reduce or simplify where we can, and the double negative here becomes positive, and that's my final result.